Periodic motion, questions 4, 5 and 6. So starting with question 4, which is multiple choice, we have a model car moving in a circular path and you are told that the radius is 0.8 meters. Also the angular speed is pi divided by 2 radians per second. Angular speed is represented by the symbol omega, and you can also think of it as theta divided by t, as angular speed is angle swept out per unit time. So what is the displacement from point P after 6 seconds? So first of all you want to identify how far the car has travelled in this circular path in a time of 6 seconds. You want to work out its position. Now it's actually more convenient to do this in terms of angles first of all. So the angle swept out is equal to the angular speed multiplied by the time. So we have pi divided by 2 times 6 seconds, giving 3 pi. Now remember 2 pi radians corresponds to 1 rotation, so 3 pi radians must be 1.5 rotations. So imagine the car going around the circle 1.5 times and it will finish at this point on the opposite side. So finally displacement is measured from P, so from P to the opposite side is equivalent to 2 radii, therefore 1.6 meters. Okay, next in question 5 we have another circular motion question where a mass is moving round in a horizontal circle as it is attached to a string threaded through a thin tube. So the larger mass is hanging vertically down here, and it's just a case of looking at the forces involved and relating it to circular motion. So here we have the general equation for centripetal force, and that centripetal force is provided by the tension in the string. And the tension in the string equals the weight of this larger mass pulling vertically down. We can then simply rearrange the equation to get an expression for the mass, which is what we've been asked for here. So that gives us answer C, mv squared divided by rg. Next we have question 6, and we have got a 0.2 kilogram mass whirled around a vertical circle. So this point here is higher, it's above this point down here. And we've been given the length of the string as 0.9 meters. At the top of the circle, the speed is 8.2 meters per second, and we are asked for the tension in the string at this point. So once again we need to understand that the centripetal force is provided by the resultant of the tension and the weight. Both the tension and the weight act towards the centre of the circle, so we add them together to get an expression for the centripetal force. Then finally, rearranging to get an expression for the tension on its own, we have got mv squared divided by r, take away the weight. Substitution of the values leads to an answer of 12.98 meters, matching answer B in the question.